Hello everyone, so today we are solving this problem largest combination with bitwise and greater than 0. So the bitwise end of an array nums is the bitwise end of all integers in nums. Okay, for example 153. The bitwise end is equal to the end operation of all these numbers 1, 5 and 3, right? So this is giving us 1. Also if there is only one single number in the array, then it would be give the value the value itself, like in this case it is 7, the end operation, because there is no other thing. So you are given an array of positive integers candidates. Evaluate the bitwise end of every combination of numbers of candidates. Means every combination means there could be many numbers, right? It's not necessarily all of them, but some set of the numbers. So each number in candidates may only be used once in each combination. So every combination we can pick only one number from the candidates. So return the size of largest combination of candidates with a bitwise end greater than 0. So basically what we have to do, there could be multiple. So for example, we are taking this array 1, 3, 4, 9, 5, and these are the binary equivalent of these numbers. Okay. So if we observe here, if we look this is the first bit, which is non-zero, right? This is 1 in this case. This is 1. This guy also have this bit 1, and if we look, this 9 also has this bit 1, and 5 also this bit 1. So we observe here we have at least 4 such integers which has first bit, means the same bit or at the very first location is same. So if we do the ampersand of all of them, this will give us a non-zero value. Okay, so how many numbers here? 1, 3, 9 and 5. Okay, if we do the ampersand of these guys, 1 and 3 and 9 and 5. Okay, this would be basically giving us a non-zero value. Why? Because we have found a common bit in all of them. So at least that bit would not go 0. So we found here how many numbers? We found here 4 such numbers. And do we have any other? Let's see. So if we go here, see here at 5 and at 4, right? We have this this bit. From the third bit, if we go from the right to left, this bit basically it is that also set bit, right? So if we do the ampersand of 4 and 5, that also will give us a non-zero value, right? But see here, this is how many numbers? Here we have only 2 numbers, but in the question it says that we need the largest set of the values which will produce a non-zero value. So in this case 4 should be our answer, even though 2 is also an eligible answer, but this is not the greatest one. So so our approach is we have to find here that out of these bits what position is basically having the highest number of the count of the numbers. Okay, now the thing is, in the question it is given, see here in the question, you can watch it here, the constraint for the numbers are given. See there, it could be up to 10 to the power 7 starting from 1, means we can have up to 10 to the power 7 value number, right, in the candidate. So we just cannot rely on these 4 bits or 16 bit, right? Whatever we just explained. So we have to know that what would be the maximum bit size out of that. So there is a formula. That formula says that if we want to know that how many bits would be required, okay, let's say I'm saying bits required, how we can calculate? We can calculate this with the log of base 2 with the whatever number. Okay, so it would be 10 to the power 7 in our case, right? Okay, 10 to the power 7 plus 1. This is basically the formula. Okay, so if we want to calculate this one, we can calculate it. How we would calculate? We can make it a log of the 10, right? This would be, if we take the log of 10, right? So we have the mathematical formula, then divide by log 10 of 2, right? That is a formula, mathematics formula. So this would be the equivalent value plus 1. So this will give us approximately value which is close to 24. You guys can pick your calculator and calculate it. So that means we need the 24 bits, okay, to accommodate all the numbers which are in this range starting from 1 to 10 to the power 7. So here we got to know that we have to have the 24 bits. So that means we have to look the set of the numbers out of these 24 bits which are having the common set bit. At the 24, out of these 24 there should be 0 to 23, right, 24 positions. So we have to find the highest number of the values having the set bit. So how to do that? That means we have to look for all the 24 locations, right? So we will do that, nothing is special. So let's how we will do, we will use a for loop starting from I equal to 0 to 23, right? And then for all the positions we'll look for this candidate variables, right? So see here, let's say we have an I which will range from I equal to 0 till I equal to 23, right? Because we have the 24 values. Now for all these values we have to go for this candidate, right? So there could be we have to use a for loop, okay? So for, let's say we have X value in the candidate. So in the X value in the candidate, then what we will do is we have to check the position. So right now we have I, right? So how we will do that? So we have to check this X, okay? If we do the X ampersand, basically the end, if we do the X ampersand with what? With the position. So ith position here, right? So what we will do is we have to look for the ith position. So what we will do? We will do, this is 1, right? 1 and left shift for I times, okay? So this will give us the value which is like ith bit would be set in this case if we apply this one. This is left shift operator. So whatever number is given here, this is I, so it will shift it, this 1. So there would be only one value and it will shift it to the ith location, right? And if we do the ampersand with this, if it is producing a non-zero value, if it is producing a non-zero value, then this will give us an indication, okay, this will give us an indication that the ith bit of the number X is basically set. So in this case what we will do, we will do this, we will have a one variable, right? We will have a variable count and we will make this count equal to count plus plus, right? So for every I, see here we have I, right? This is a for loop. For every I we will go to every value in the candidate and we will check. Let's say in this case, initially let's say we started I equal to 0. So for 0 we will check in all the values of this, right? That hey, is it set or not? Is it set or not? Is it set or not? With this formula, right? So if it is set, we will make a count plus plus. That means at the end of this, we would be having that at the ith position, how many of these numbers having a bit set, okay? So this count would be give us value. So similarly, we will go for the 24 times and we will check that whoever is giving the highest number of count, that would be our answer. So this is what we are gonna do. And yeah, so let me show you my code for this. See here, what I'm doing is I just declared one variable int max frequency, initially 0, and this is my for loop starting on 0 less than 24. So see here, I just created one more variable to count the local frequency. So see here, for every I position out of these 24 positions, for every I am going for all the values of our candidates, right? So we pick the X value. Now see here, we are checking that if this position, the ith position ampersand with X, if it is producing a non-zero value, this says that the ith value of this number X is basically set. So that is why I am making frequency plus plus. So see here in this for loop, we are checking for all the numbers for the ith position, whether this is a set bit or not. So after this, we would have the total frequency of this ith position, which are having set. Now see here, I am checking for the maximum value because we need the maximum frequency. And then I am returning this max frequency. So let me try to run my code. I am executing it. Yeah, so it is working fine. Let me try to submit it, which I have already submitted, but still I am doing this for the sake of you guys. So yeah, it is 93.65% faster. So we are not using any extra space, right? We are just using the some variables, and we are doing the single traversal. So you guys can take it as a follow-up. You guys can do it with the extra space as well, but in interviews go for this kind of approach. So we are taking O of 1 space complexity and O of n is the time complexity. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.